Alrighty, in this video we're looking at graphs of other trig functions. We've already observed sine and cosine, so we're working with the rest of them today. Our objectives are to graph the tangent and then the three reciprocal trig functions, and to determine the domain, range, and any asymptotes of our trig functions. Let's talk about the tangent function first. When you graph the tangent function, it's going to be the y-coordinate of the intersection of the angle's terminal ray and the tangent drawn to the unit circle at 1, 0. So looking at this little graphic here, you'll see on the left-hand side the unit circle, and the rays have been drawn through some different rotations around our circle. There is a vertical line that is just barely touching the circle. That is the tangent line. Let's look at that blue ray that is intersecting the tangent line. The angle there is pi/6, or 30 degrees. You'll notice that the height where that terminal ray intersects the tangent line, that is the height on the graph that you see just to the right. You could measure it with your fingers there and measure from 0 to where pi/6 intersects that tangent line. That is the height of the graph of your tangent function. Similarly, look where pi/4, that red line, intersects the tangent line. That height is actually just at height of 1. Pi/3, that green ray, it's quite a bit higher, and that height is a little bit over 1.5. Also, let's go back and look at that kind of purple line. That purple line, it intersects it at a height of 0. They are perpendicular to each other and they intersect at a height of 0, and that is why you have that point 0, 0. Now, I want to make you aware of those kind of dashed vertical lines. Let me go to the next slide here. I have highlighted for you in the unit circle the ray that would be going 90 degrees. Now that ray is parallel to the tangent line. They are never going to intersect. They're parallel. That means there's never going to be, in the graph of the tangent function, a point there. You're never going to touch a y value for pi/2 for 90 degrees. Those places right there where those dashed lines are, they are asymptotes, and they happen at multiples of 90, because every time that you are either working with 90 or at 270, or however many times you rotate through that, you're always going to be working with a line that's parallel to the tangent, and it's never going to intersect. So you kind of have these little kind of squiggly lines that go for the tangent function, but they're not a nice continuous wave. They're like these little divided waves. And when you have functions like that that are divided, that have asymptotes, or if they had jumps or holes, we call that discontinuous. And that is true for our subsequent function as well. We're going to see a lot of discontinuous functions in this lesson. So let me show you another. The cotangent. It is like the tangent, in that it has a period of pi, but now the asymptotes are going to be at multiples of 180. So what's happened here, and you'll want to take note of this, the waves kind of go down from left to right, down from left to right, where the tangent was going up and going up and going up. These are going down. Also, for the tangent function, at 90 and 270, there were asymptotes. Now, there are zeros. So it kind of flip-flops. Where there once was an asymptote, now there's a zero. And if for the tangent it was a point that was a zero, now it's an asymptote. You'll want to put those side by side to kind of contrast them. Let me talk to you a little bit now about the cosecant function. It is, if you recall, the cosecant function is the reciprocal of your sine function. So if you wanted to actually graph a cosecant function, the first thing you'd want to do is graph the sine function, and you can see that graphed in that black dashed line above. That is your sine function. It's kind of snaking between 0 and 2 pi. After you draw the sine function, you would want to draw the asymptotes where sine equals 0. And that is going to be where the zeros happen. Remember, zeros are the x-intercepts. So you'll see those kind of dashed blue lines throughout that sine graph. Those dashed blue lines are happening where your sine curve is intersecting the x-axis. Those are where your asymptotes will happen. Next, you'll want to plot ordered pairs at the crests and troughs of the sine function. So those are the red dots. The red dots have been plotted at the crest and at the trough of your sine function. Also, after you've done that, you want to find those green dots. Now, to find those green dots, that's going to happen. Let's think about this very carefully. Sine and cosecant are reciprocals. So it would make sense to say that wherever sine is 1/2, cosecant is 2. Right? Because that's just the reciprocal of 1/2. So if you're talking about sine being 1/2, then cosecant would be 2. And if you take a look at your golden table, you'll know exactly where sine is 1/2. If you'll take out your golden table right now, sine is 1/2 at pi over 6. And so at pi over 6, cosecant is 2. Look down on your golden table some more. Sine is 1/2 at 5 pi over 6. So if at 5 pi over 6 sine is 1/2, that means that cosecant would be 2. And that's where those little green dots are being generated from. Now that you have kind of those asymptotes and those ordered pairs, you can create these little, they look like little U's almost, just staying between the guidelines and going through those points. And that's a cosecant function, the reciprocal of sine. And that leaves the secant function. Now, the one that we are going to look at has been modified a little bit. It is 2 secant x. That 2 is the amplitude. So when we have to get started graphing here, we're going to actually sketch the graph of 2 cosine x to take into account that change in the amplitude. So that's that kind of black dotted line that you see through there. That is 2 cosine x. Next, we draw the asymptotes where cosine of x equals 0. We're drawing those asymptotes through the zeros of your cosine function. Do you see those blue dotted lines? They're going through the cosine function where it crosses the x-axis. Then we, again, kind of like the cosecant, we plot those red dots, excuse me, at the crest and the troughs of the cosine function. Sorry. Now, again, like we did for the previous function, cosine of x, wherever it's 1/2, secant is going to be 2. So look at your golden table. Cosine is equal to 1/2 at pi over 3. Cosine of negative 1/2 happens at 2 pi over 3. So now we're not going to plot the points at 1/2. We're working with secant. We'll plot them at the reciprocal of 1/2. So wherever you look and see 1/2 for your sine function, you're going to go to 2 for the secant. But this secant function is 2 secant x. So you're going to have a little bit of a change in the amplitude there. And you're going to increase that to 4. And that's where those green dots have been plotted. You'll see that the output there is 4 at pi over 3 and at negative pi over 3. Where for the cosine function at pi over 3, it was actually a little bit lower than that. And that kind of is a walkthrough of those functions. We're going to work with them in some practice now.